Welcome to a new test and teardown video. This time it's a signal corps military signal generator, but it's a pulse generator as well. And it's called TS-419A-U. It's made by Collins, Iowa. And unfortunately, as you can see here, it is 115 volts only. There's no way to fix this internally. They made the transformers with only one primary winding. And it's also written here again. So that is unfortunately how it is with this unit. It covers the frequency goes from 900 to 2.1 gigahertz. So it's quite fast. So that will be the base frequency in CV, constant wave mode. It's of course just a signal generator. But you can make this pulse. And you have the pulse delay, you have the pulse rate, and it can synchronize to external input signals, and then you can create some pulses from those syncs. So I think this is for testing radar systems in the good old days. I don't know exactly how old this one is, but I think about 1950. If you know more about that, please comment on its age. I was able to find a tiny little bit of information online about this. It says something about 20 kilos. Well, I measure this to 20.5 kilos. I also found just tiny little bits of schematic or some drawings. I mean, I didn't find a lot. I found an eBay. One is for sale on eBay. I think it's $150, and I find another sales at 130 euros for a much more beautiful unit. But in both cases, they say we don't know if they work or not. It's for spare parts. Buy it as it is. I got this one for free. One of my regular sponsors. So thanks again for giving me all sorts of cool equipment to play with. I'm really happy about all the support that I get. So I want to open and inspect before I do anything further. I just wanted to show a tiny little detail here. Fuses and then spares using sockets and everything here on the front. I think that is super neat. And another thing, this cable here is also very old. Try and hear this when I bent the cable. Can you hear? Can you hear? It cracks inside, and it feels like it's cracking. And that's simply because this type of isolation, it just dries out and cracks. Yeah, this is an old American connector. Yeah, definitely original. We are now inside this fantastic unit, and I mean, it's really clear this is military grade. So nice, and that is some. As you can see, it's of course full of tubes. I counted 22 tubes, so I hope I did this right. We will see if I screwed it up. Of course, everything here is full of nice stickers. All those OA, this and that. There'll be voltage reference tubes. And here we go. Look at that. Some nice. I think this is of course not original, because you can see they don't even fit. Or the sockets, they are too close. So this can't be original. And down here we see some more tubes, probably in the power supply. And it's not super obvious to see, but yes, we got 4 of these down there. And yeah, 6v6. And a nice warning about 925 volts around this potentiometer. So there's a huge potentiometer here for very high voltage, and it is coupled to the frequency selection. So when I dial the frequency, see all those gearboxes here also move that potentiometer. So it's of course compensating for the power drive and all that kind of stuff. I think that one there is a little, no, this is just an isolator, but in here there is also a little thermistor that measures the power level, and that power level is then in a feedback loop to make the output power constant. Yeah, maybe it's in here, right? But somewhere in here, so you can just change this thermistor, and normally you have a spare thermistor right here, so you could right there. But that is not in my unit, unfortunately. What have we got here? Some switches for the different modes. Oh yeah, about the output power. So in here there is a piston resonator with another tube inside. So this tube is in here between these two ends here. And here there's a piston that moves up and down that creates a resonant system for that tube. And the output is coupled. There's at the end of this another little piston here, but it's just something that moves with a little gearbox. At the end here there's a little pickup coil or a little pickup antenna that goes to that coax cable that is the output. And when you move your attenuator, your output power, look at again, gearbox, and then it moves that coupler closer and closer and closer. I get more and more output power. So that is how the output attenuator is made, simply mechanical by distance. Yeah, there's tons of 6v6 in this one. What, with 4 and 3 more here? Yeah. Oh, we also got another little funny component down there, and tons of trimmers, and the bottom of the unit is a sight. Oh, look at that. Look how beautiful it is all made. I am a little bit impressed. This reveals somebody spent so much time designing and documenting and manufacturing this. It's so beautiful. We got a little bit of nasty corrosion here. It reveals this unit had a tough life. Oh yeah, about the mains entry. So originally there's a really weird connector here, and of course you can't find a mating connector for this. So I don't know why they just made it so ugly. It could have been a little bit more pretty. But I want to show you about these cables. When I take this one and do like this, can you hear it? Click, click, click. See? It cracks. So there's no... Yeah. That is bad. So I have to replace the power cable, and then maybe... I don't really see anything that should prevent me from trying to fire this up. So let's dim the light a little bit for action. So first, let's see if the mains switch is working. Crank down, I don't know if, can you see this? Yes, I can. Maybe I can move this a little bit closer so we can see what we are doing. Here we go. So this is my mains input variable, and I'll just give it a little bit. And it is using a little bit of power. So it's probably just the mains filter. And I will try now and turn on, this is just 40 volts, just to see what happens at 40 volts. So at 40 volts, it's using a half an amp. And then it goes down, down, down. And this is a good sign. This means I'm actually heating up the filaments a little bit. I actually start to see something here. So 40 volts, we should of course remember it is only supposed to run on 115 volts. We have now bright power. And we see something here again. So crank it up to 100 volts. And how about 110? No smoke, no nothing. So this is 115. It is using 170 watts. So that is good. So what we want to do is we want to go into the power set. Can't remember, are we doing it like here? Doing it in 0 set. This meter just goes all the way to the max. Why is it doing that? I don't understand that. This shouldn't do like that. I got no response of anything here. It's using 172 watts. I think I'll go and grab my spectrum analyzer and see if there's any output. At least the meter shows something, so that can't be that bad. "14 watts of idle." You crazy. So that is why there's a heater. What kind of heater is that? I don't understand exactly what it is it's heating, but okay, that is interesting. So there's a temperature regulated something in here, or something that is supposed to be kept warm. And what is this? Turns off? Yes, it does. How nice. I kind of like that. This is old style with those bulbs. Lovely. So I think I'm able to show everything here on one screen all together. So let's just crank it on and see if there's any output. I am now in CV mode. Oi! Can you see what I see here? So center frequency is 950. So let's give it a span of 50 meter. Look at that. So we got output. It's a little bit low, but there's no response here. Oh, power set here. Yay. So I've put this for minus 20. All I have to dial it here is minus 30 on my meter here, because I have, of course, my own little attenuator here, because I don't want DC in here. I don't want strong RF to blow up my spectrum analyzer again. So it works. And the frequency is really close to being correct. I did not expect that. Hey, let's try to test the max frequency and all that. So on my way to the max frequency, I just stopped here just for fun. So this is 1200 as far as I see. And then I just hit the marker center, and look at that. That is very close to 1200 for a unit that is, I mean, that old. I am a little bit impressed. So I think this is as close to 2100 megacycles. And then it is only 2069. Okay, so it's a little bit off. And again, that will be my signal level. not bad. Yeah, it's using 175 watts at the moment. Could be fun to see if we can get some of the pulses to work. I think we've got internal oscillator as well here. I don't know if that is right. I'll try and play a little bit with this and see if I can get some modulation here. Let me show you how you can easily blow up your equipment. I just measured, of course, on the external modulation. I didn't see any voltage here, but I didn't test synchronization input, and I'm just using an external generator at the moment just to see if I can get any modulation and anything like that. Oi, how numb. How numb is that? So this is the DC voltage output on the sync input. So what happens when I poke around, poing, I get the full overvoltage. So that's more than 60 volts in a short pulse like that. See? Kapow, and smash off your equipment. And when I put this in to my generator, obviously it says, oops, warning turned off and overvoltage detected. I hope it still works. Otherwise, I am going to fill this thing with gunpowder and make a little ritual in the garden. But let's have a look what happens here. So, I just really love this, the build of this thing. So I removed all the metal shields for all the tubes so I can easier see what is going on. And this little shield here on top of this main modes of operation switch. Look at that beautiful switch. And there's another really cool design idea here. Can you see that all the wires, they go through here? Isn't that just a beautiful idea? Oh, I love it. And there's also another little funny thing. Look where I'm pointing here with the screwdriver. Can you see the white nasty fungus? Here you go. It's probably, damn it, this light is annoying. Here you go, down there and down here. And this is actually causing all sorts of problems. Yeah, well. I have to clean up everything and make it super shiny. Yeah, I think I earlier said about the mains input. Only 115. There isn't any extra tapping here on the input side. So this is the high voltage. So we've got quite a lot of high voltage here. And then there's the low voltage transformer. That is this one. And again, the primary side is only made for USA power. Yeah, that's just how it is. What kind of nasty corrosion is this? Unprotected iron. That is not a good design decision. Everything else is made of metals that will not corrode. I mean, super fast. This is some sort of a nickel plated something, and I think there's a few more things I really should show you, and that's probably we need to access this main oscillator tube. And also we got a little bit of corrosion in there, so that will be the DC, the filament, and the grids and all that kind of stuff. But we should be able to access that one somehow. Maybe it's this screw. Yeah, let's see how we do that. About the huge rectifier tubes, I just took them out of the sockets. You can see here normally those holders, they are locked to hold the rectifier tubes, and those holders didn't fit the kind of sockets we got here. We can see the number is supposed to be 5R4GY, and if we look here, it's called 5R4WGB, so it's not exactly the right tube. And also look at the corrosion here. This is causing all sorts of loose connections, and it's a good idea to clean your sockets when you're doing service on really old stuff like this. This is not good at all. But that's some beautiful high power, high voltage rectifier, double rectifier tubes. Yeah, I took them out so I can access this more safely. When I'm moving around here, I could easily, it doesn't take much to hit a tube and then crack them, by the way. So that is my point here. And that is one sexy socket. Wouldn't you say that? So in here we got inductors and capacitors for isolation to this tube socket. So in here I think there is a special way to get this tube out, by the way. You either press something, or I can't really remember how to do that. Maybe you just pull, or you need to loosen something. Yeah, that is how it is. So you loosen this one, and then then you can pull it out. I'm pulling out this screw, and then what the heck, ball bearings. So you can screw this and then it still runs smooth here. How is that? That was not so easy. But of course you can imagine. You can even see the marks from all the different blades that contacts this tube. We also got some green nasty corrosion here at the top. So this tube is Sylvania 6BM6. Oh, that green nasty. I have to clean this. Well, that is one beautiful tube, wouldn't you say that? Nice. Let's see if we can get some light in here. So this is the socket with all the different parts in there. So like I said before, there's a piston that makes this resonator longer and shorter, and that is how you adjust the frequency. So it's all a mechanical thing, only defined by the dimensions of this oscillator. I just think everything here is so fantastic, beautiful. You could easily handle a few more seconds of this. Well, there's not a lot more I wanted to show you about this instrument, to be honest. I just want to put it back together and maybe see if I can figure out the modulation inputs and how that is working. But other than that, I think I want to say thank you very much for watching so far. See you around. Bye bye.